Welcome to episode 28, Streaming Analytics with PubSub and Dataflow, where we explore how Google Cloud enables real-time insight through managed streaming pipelines. In many organizations, data no longer arrives neatly at the end of the day. It flows continuously from applications, sensors, and services. Streaming Analytics processes that data as it happens, enabling instant feedback, anomaly detection, and live dashboards. Rather than waiting for a batch process to complete, decisions can be made in near real time. PubSub and Dataflow work together as the backbone of this capability. PubSub captures and distributes messages, while Dataflow transforms and delivers them. This combination supports massive scale with reliability, turning raw events into actionable signals the moment they occur. PubSub, short for Publish Subscribe, is the message delivery service at the center of streaming on Google Cloud. It decouples data producers, called publishers, from consumers, called subscribers. Publishers send messages to topics, which act as named channels, and subscribers receive messages from those topics through subscriptions. This design scales horizontally, allowing thousands of publishers and subscribers to operate independently. For instance, mobile apps, IoT devices, and back-end systems can all publish events to a single topic that analytics systems subscribe to. PubSub ensures durability, scalability, and resilience, serving as the nervous system that routes information between systems in real time without requiring them to know about each other's details. PubSub supports two subscription delivery methods, push and pull. In a push subscription, PubSub sends messages to a specified endpoint, such as an HTTPS service, as soon as they're available. In a pull subscription, consumers fetch messages when ready. Each approach suits different workloads. Push works well for continuous processing pipelines or webhook integrations that expect steady flow, while pull gives consumers more control over pacing and error handling. For example, a payment system might use pull to manage transaction spikes safely without overloading downstream services. Selecting between push and pull affects latency, throughput, and operational complexity, so it's often guided by how predictable and scalable message consumption must be. Ordering, retries, and dead letter queues are vital for reliable message delivery. PubSub guarantees at least once delivery, meaning duplicates can occur during retries if acknowledgements fail. To maintain order, messages can include sequence keys, ensuring that related events are processed in order. Dead letter queues capture messages that repeatedly fail, preventing pipeline blockage while retaining problematic data for inspection. For instance, if malformed events cause parsing errors, they can be rerouted for later analysis rather than dropped. These mechanisms ensure resilience, no event is lost, and every issue can be addressed systematically. Reliability in streaming comes from designing for imperfection, not assuming it won't happen. Dataflow, Google's fully managed service for stream and batch data processing, builds on the open-source Apache Beam framework. It provides a unified programming model for both modes, meaning the same logic can process historical batches or live streams. Developers define pipelines as code, describing how data flows through stages of transformation. Dataflow handles scaling, parallelization, and fault recovery automatically. This serverless model removes the burden of provisioning or managing clusters. For example, a developer can deploy a pipeline that processes millions of events per second without predefining capacity. Dataflow's integration with PubSub, BigQuery, and cloud storage makes it a central player in end-to-end data architectures. A Dataflow pipeline consists of sources, transforms, and sinks. Sources ingest data from systems like PubSub or cloud storage. Transforms clean, aggregate, or enrich the data, filtering noise, joining with reference datasets, or calculating metrics. Sinks deliver results to destinations such as BigQuery, dashboards, or alerts. This modular structure mirrors assembly lines in manufacturing, where each stage refines data quality. For instance, a pipeline might read from PubSub, parse logs, compute error rates, and write to BigQuery every few seconds. Defining pipelines as code enables testing and version control, turning data flows into maintainable software assets rather than fragile scripts. Windows, triggers, and late data management are core concepts in stream processing. Because data arrives continuously, it must be grouped into logical windows, time intervals such as 1 minute, 5 minutes, or hourly, to compute meaningful aggregates. Triggers define when results are emitted, either when the window closes or earlier for partial updates. Late data, which arrives after its expected time, can still be processed depending on configuration. For example, a system might tolerate 5 minutes of lateness before finalizing results. Managing windows and triggers ensures accuracy and timeliness, balancing precision with responsiveness. Streaming analytics succeeds when it reflects reality as closely as possible, even amid unpredictable delays.
Exactly once processing and item potency guarantee correctness in the face of retries and duplicates. Dataflow achieves exactly once semantics by tracking message acknowledgements and processing state across parallel workers. Impotent transformations ensure that reprocessing the same input yields the same output, preventing inflation of counts or totals. For example, incrementing a counter only when a unique event ID appears keeps metrics stable even if messages repeat. These mechanisms are essential in financial or transactional pipelines where double counting could lead to false alarms or losses. Reliability in streaming depends as much on thoughtful design as on the technology itself. Clean logic prevents cascading errors downstream. Enriching streams with reference data turns isolated events into contextual insight. A click event becomes meaningful when joined with user profiles, product metadata, or location details. Dataflow supports side inputs and lookups that merge live events with static datasets efficiently. For instance, an online store might enrich purchase events with inventory levels to monitor stock in real time. Careful caching and windowing prevent stale data from distorting results. Enrichment transforms streams from raw signals into stories, events interpreted within their environment, enabling smarter alerts, forecasts, and automated responses that match actual business context rather than isolated numbers. Writing results to BigQuery safely completes the streaming analytics loop. Dataflow provides native connectors that load data into BigQuery with schema enforcement and transactional guarantees. This allows dashboards and machine learning models to consume up-to-date insights directly. To avoid duplicates, inserts use unique identifiers or deduplication windows. For example, streaming sales transactions into BigQuery allows real-time revenue dashboards to update instantly while preserving historical accuracy. BigQuery's separation of storage and compute means it can ingest data continuously without slowing queries. This seamless integration demonstrates how streaming pipelines and analytical warehouses now operate as a unified ecosystem. Monitoring lag, throughput, and costs keeps streaming systems healthy and economical. Lag measures how delayed processing is relative to real time, while throughput tracks the number of events handled per second. Both indicate efficiency and scalability. Cloud monitoring provides dashboards and alerts for these metrics, helping operators detect backlogs or performance bottlenecks early. Cost monitoring ensures pipelines run efficiently, as continuous processing can accumulate charges quickly. For example, tuning window sizes and parallelism often reduces compute overhead. Observability transforms operations from reactive troubleshooting to proactive optimization, maintaining real-time insights without runaway expense. Common use cases for PubSub and Dataflow span industries and functions. In retail, they power live recommendation systems that adjust offers based on recent behavior. In cybersecurity, they drive alerting pipelines that flag anomalies as logs stream in. In finance, they enable fraud detection and transaction scoring within seconds of event arrival. Streaming also supports IoT analytics, supply chain monitoring, and even smart city infrastructure. Yet pitfalls remain. Overcomplicated pipelines, poor schema management, and lack of backpressure control can create fragility. Successful implementations start small, test incrementally, and evolve toward higher complexity with strong governance in place. Streaming analytics delivers real-time insight with real impact. PubSub and Dataflow together form a powerful, managed foundation for continuous intelligence, seeing events as they unfold, not after the fact. They bring agility to monitoring, forecasting, and automation, allowing organizations to respond instantly to change. The shift from batch to streaming is not just technical but cultural. It transforms how businesses perceive time and information. With thoughtful design, governance, and monitoring, streaming analytics becomes a living system of awareness, powering data-driven actions that keep pace with the world's constant motion. Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.